All right. So the immune system. First of all, white blood cells, which we talked about last year. What's the kind of fancy name for the white blood cells? Leukocytes, yeah. So there are leukocytes. Of course, it's written right below it. There are 5 different leukocytes that we've learned. Do you remember any of them from last year?
Monophils.
Monophils.
Basophils.
Hold on, sorry, not monophils. Monocytes.
Oh, yeah, monophils. Oh, yeah.
Basophils is correct. Monocytes, basophils, any others? Lymphocytes, obviously, right? That's the one we're going to be dealing with a lot today, needed in 533. Lymphocytes. 2 other ones?
Wait, one's really weird, isn't it?
Okay, then.
Eosinophil?
Yeah, eosinophil. And the last one starts with an N.
Neutrophil?
Yeah, neutrophils. All right, an easy way to remember this, never let monkeys eat bananas. And it also gives you the order of prevalence in the body. So we have the most neutrophils, never. The next highest number of white blood cells we have are the lymphocytes, let monkeys eat bananas. And those are the 3 lesser common lymphocytes. All right, 2 things that we didn't talk about necessarily last year, the antigen and the antibody, but most people have a pretty good understanding of what these are. What is an antigen? It is kind of like an intruder. Not necessarily have to be a virus, though.
Foreign object in the body.
Yeah, that's closer. A foreign object in the body. An antigen is anything that can provoke an immune response. All right, so anything that can provoke an immune response is going to be an antigen. If you notice underneath, I wrote a little note to you. All cells are marked with antigenic receptors, meaning that all cells in your body have antigens on them, have these little receptors that mark it as an antigen. All right, those are receptor proteins that antibodies are going to bind to in order to invoke the immune response. However, if it's your body's own cell, it's a self-antigen. And your body doesn't recognize it as foreign, so it won't have an immune response. This kind of explains how autoimmune disorders work, is that suddenly your body starts thinking the cells that are marked as yours are not yours anymore. It doesn't recognize them as self, because all cells have antigens. That also explains why transfusions can cause problems, because my cells are marked Mrs. T. Gabby's cells are marked Gabby. If I put Gabby's cells in my body and it doesn't match the same antigenic receptor that mine has, that's why I'll recognize her cells as foreign, and that can cause a problem. So all cells are considered antigens. It just depends if your body thinks it's a foreign antigen or a self-antigen. All right, the next part, an antibody. What is an antibody? All right, people think it fights antigens. It actually doesn't do the fighting itself. The antibodies are proteins that basically just mark the antigens. These are proteins called immunoglobulins. And these immunoglobulins are going to bind to the antigen and mark them for destruction. That binds an antigen and mark them for destruction. Notice I didn't say it kills the antigens, because they don't. All they do is tag the antigens as, hey, this is something bad. Other cells are going to come kill it. There are cells called NK cells, which are natural killer cells. And we'll also talk about cytotoxic T cells. Those are going to be things that actually destroy the antigens. There are 5 types of antibodies. We abbreviate them IG for immunoglobulin. And then they're named after the type of proteins that actually, the different protein chains that make these immunoglobulins up. So we have IgA, IgG, IgD, IgM, and IgE. We're not going to focus on all of these. We're just going to lump them all together and talk about them as antibodies. If you take an A&P class or an immune class in college, you'll learn each of the roles of each of these. We're not going to do that here. All right, so now some of the new stuff that you covered, that you hopefully covered when you looked at 533. We have two kinds of lymphocytes. First of all, the B cells or the B lymphocytes. Obviously, since it's a lymphocyte, right, it's going to be a white blood cell. Where do these B cells mature? Where? Yeah, in the bone marrow. And that's where they get the name. The B for bone marrow. Right? What's the function of the B cells? Ultimately, what's the goal of the B cells?
Recognize an antigen and produce antibodies?
Yeah, they're going to produce the antibodies. All right, and here's how they do that. When they face a foreign antigen, like it says here in the notes, when they face a foreign antigen, they turn into either plasma cells or memory cells. So it'll basically start dividing, and when it divides, it either becomes a plasma cell or a memory cell. And each of these cells does something different to help with this immune response. What does the plasma cell do? Yes, these are the cells that actually secrete the antibodies. So these secrete specific antibodies for a particular antigen. And I know I'm being a little repetitive with the specific and particular, but that's really important. The antibodies are for one particular antigen, not for anything bad in your body. Any antibody will go attack it. It's a specific antibody that will bind to one particular antigen and that antigen only. All right, to give you an idea of how hard these plasma cells work, they actually produce 2,000 antibodies per second, which is quite impressive. They're cranking out these antibodies very quickly. The next thing that the B cells turn into, so some of them will turn into these plasma cells, the rest of them will turn into these memory cells. What are memory cells? Yeah?
The muscle in the body that will recognize the antigen again if it comes back and quickly reproduce.
Yeah. Exactly. These are going to be cells that can mount a humoral immune response. I'll explain that in a second. We'll say mount an immediate humoral immune response. A humoral immune response means the response of secreting antigens. So making antibodies. Obviously would not want to make antigens. So these cells are the ones that are going to make the antigen or antibody specific to the antigen. They make them if faced with the same antigen again in the future. The same antigen in the future. So this way, if you get infected with something your body has already fought off, your body knows how to fight it off again and will do it pretty much immediately. That's because the memory cells remember that antigen and can start producing the antibodies specific to that antigen. Again, this only works if it's an antigen that it's faced before, right? If it's the same antigen in the future. The other type of lymphocytes we have are the helper T cells, or the T lymphocytes. Where do these mature? Yeah, the thymus. And that's where it gets its name, that T for thymus. The T cells. What are the functions? What's the function of the T cells?
Activate B cells.
Exactly, they're going to activate B cells. And does anyone know what they release to activate the B cells? The cytokines, yeah. So these are going to aid in the activation of B cells by releasing cytokines. And cytokines are a new word, so if you don't know what cytokines are, these are molecules released for cell signaling. So if one cell wants to signal another cell, it'll release these cytokines. These are molecules or chemicals that are secreted from one cell to let another cell know what's going on. So the helper T cells will secrete cytokines, telling the B cells to start proliferating and making the plasma cells, turning into plasma cells and memory cells. One thing I put here to note, there are also cytotoxic T cells, a different type of T cell called a cytotoxic T cell. It's exactly what it sounds like. Cyto meaning cell, right? And toxic meaning something that's toxic or bad. These are cells that kill other cells. They're different from the helper T cells. They're going to kill the foreign cells. So like I said before, the antibodies and the antigens, right? The antibodies don't actually kill anything. They just tag it so things like cytotoxic T cells can come along and destroy them. Another thing I put to note here, this stuff is way more complicated than what we're covering here. The way the T cells signal the B cells is very complex. So we're not covering all the details. Again, in a college A&P class, you may learn that a little bit more. The last thing we have to talk about are macrophages. These are not a type of lymphocyte. Macrophages are large cells that come from monocytes. If you remember, monocytes are one of the types of white blood cells. So the monocyte will turn into a macrophage. What do macrophages do?
Engulf the virus.
Yeah, exactly. They're going to engulf the virus. They're going to phagocytose, which means to eat another cell, the virus or whatever the antigen is. So they are going to ingest the antigen to destroy it. All right, this is not all they do. They actually have a slightly more complicated job than that. To do this, like we said, they're going to ingest or phagocytize, which means to ingest or kind of take in the antigen, and obviously destroy it. Then they're going to take a portion of that antigen to the helper T cells. Then they present a portion of the antigen to the helper T cells. And you could continue to write here, but we already have it written, so no need to be repetitive. What are the helper T cells then going to do? Exactly, they're going to do their job. The helper T cells are then going to activate the B cells and tell the B cells, hey, we have an antigen, start splitting up into the plasma cells and memory cells and start producing those specific antibodies. So at this point we have a lot of cells that are doing a lot of different things. To help, maybe if you're confused at all, I just want to kind of quickly divide up what these different cell types are. First of all, we have the white blood cells, right, also known as leukocytes. There are 5 types of white blood cells, right? Never let monkeys eat bananas. I'm not going to write them all out because you have them written up above, trying to save a little time here. The lymphocytes, there are 2 types, right? We have the B cells, so the B lymphocytes, and we have the T cells, the T lymphocytes. B cells are going to be what divide into memory cells and plasma cells. The T cells, we have 2 types of T cells. The helper T cells, which is what we focused on a little bit more here, and then there's also the cytotoxic Those are going to be what actually destroy some of the foreign cells. The only other white blood cell we really talked about today are the monocytes. The monocytes are going to differentiate and turn into macrophages. So looking at these, basically kind of if you look at the ends of all these, we've got 5 cells, right? So the macrophages are going to come in contact with the foreign antigen. They're going to present that foreign antigen to the helper T cell, saying, hey, look, I found this foreign guy in our body, let's start destroying it. The helper T cell will then start activating the B cells, which will turn into the memory cells, so that if we get faced with that same antigen again, we're prepared for it, and plasma cells to make antibodies for that specific antigen. And then lastly, the cytotoxic T cells can come and destroy any antigens marked by the antibodies produced from the plasma cells. Make sense? All right. If you take a look here, I kind of wrote out your flow chart. It's not obviously in the shape of a flow chart, but this kind of explains how all of this fits together. So if you notice, the antigen, which is the bad thing, of course, we're talking about a foreign antigen in this case, not a self-antigen. The foreign antigen is going to enter the body and it's going to get trapped in the mucus. It gets trapped, but somehow the antigen slips in. There's a ton of different ways. Even when you brush your teeth, that puts teeny tiny little cuts and little spaces that can allow antigens, bacteria, and stuff in. Your digestive tract, there's different areas that antigens can get in. So somehow the antigen gets in and starts reproducing. So now it's making a whole bunch more. We'll say this is a virus, right? It's reproducing, making more and more of that virus. One happens to get caught up in the lymph, which is that liquid that's just kind of floating around. So it's going to enter the lymph vessels and the lymph nodes, because remember they have leakier vessels, so we can get that virus in there. Here, a macrophage is going to come across it, probably in a lymph node, because we'll have some extra white blood cells, macrophages, and things like that. That macrophage is going to engulf it and present that receptor protein that's on the antigen. It's going to present that to the helper T cell, saying, hey, look what I found. There's this foreign guy in the body. We already know the helper T matures in the thymus. The helper T is going to release those cytokines, the chemicals and molecules released from one cell to tell another cell to do something. That will activate the B cells, which we know matured in the bone marrow. Those B cells, eventually we're trying to get them to do their goal, which is to produce those antibodies that are specific to that particular cold virus and that cold virus only. The B cell splits into the plasma cells, which we know actually make the antibodies. They're going to make those specific antibodies. These then are just going to float throughout the blood and the lymph, and they're going to mark any cold viruses they come across for destruction. They're going to kind of tag them as bad. Then the memory cells are going to be created from the B cells. These are going to be created so if the virus enters the body again, there'll be an immediate response. Basically, that's immunity. Your body can become immune, and that's why you shouldn't be able to get, as long as your immune system is working the way it should, you shouldn't get sick from the same virus more than once. All right. For my flow chart, I have a separate document posted that explains the flow chart, kind of putting this story here into the flow chart, and then you can use that to compare to your flow chart. If you have any questions, just make sure you see me. The next thing I want to talk about is the graph, and explain what this graph is showing you for the immune response that you had to do for 533. So pull out your 533 graphs. I'm going to just kind of do a rough graph, and you should get the basic idea. Time should be along the x-axis, and the y-axis should be the antibody concentration. Meaning how many antibodies your body has been able to produce because this foreign antigen is in your body. This is your immune response. The first line is going to be from antigen A. And it should look something like this. There should be a first smaller bump and then a real steep, real tall second bump. This was your first exposure to that antigen, and here's your second exposure to that antigen. Your next line should kind of start later, because that's when you first get exposed to the antigen B, and then should have a small bump with it. So the blue line should be antigen B. What's happening here is that your antibody concentration happens kind of slowly and it can't produce that many antibodies. That's because this is your first exposure to antigen A. So your body has no preparation, right? It doesn't have any immunity to that antigen. So your body has to basically start from scratch when it's building these antibodies. And as it builds these antibodies, because it doesn't have any prior knowledge about how to build them, and it's never faced this antigen before, it takes a little bit longer. When you first get exposed to that antigen, your body, the T cells will signal the B cells to produce antibodies. Actually, the macrophage will most likely capture that antigen, present a part of it to the T cell, then the T cell will release cytokines to signal the B cells to split into plasma cells and memory cells. The plasma cells will be what produces these antibodies and make this line. The memory cells are going to wait and just be ready for the second. All right. For antigen B then, you get exposed to antigen B the same time you get exposed for the second time with antigen A. If you notice antigen B, the hump should be about the same size and shape, kind of similar to your exposure to antigen A. The reason is for the exact same situation. When you're first exposed here, this is the first time you're exposed to this antigen, so your body doesn't have any antibodies built up for it. Your body needs to mount its immune response, basically starting from scratch again. So that's why it's going to take a little bit longer, and you're going to get sick. That's the feeling of a sore throat. If you notice, when you get exposed to antigen A, the response is much larger, meaning your antibody concentration over here on the y-axis, you notice the antibody concentration is much steeper, meaning it makes the antibodies much faster, and the max is so much higher, meaning it makes way more antibodies than before. This is because you're immune to it. Your immune system is ready for it. You have the memory cells, so when you first get exposed here, your memory cells start signaling your body and start signaling that immune response, and antibodies are produced almost immediately. So that's why we produce so many more and so much more quickly. You don't feel sick from antigen A. You've experienced none of the same symptoms because your body produces so many antibodies right away from the exposure to help prevent any illness. Your immune system takes over. That's why we would consider someone immune to something. With antigen B, you still feel sick, you get the sore throat, and you don't have as many antibodies because you didn't have the memory cells and you aren't able to mount the response as quickly. Like I said before, you're starting from scratch. That's basically what's going on in this for this graph. All right, that should cover pretty much everything from 533. The notes kind of summarize it. I went over the graph that you had to do. On edline, there will be a flow chart explaining the flow chart you were supposed to make, basically my version of the flow chart. You can check your flow chart against that. This is the graph, and the notes pretty much summarize everything. There are also conclusion questions. There's a conclusion question key for 533 that you'll be able to access on edline. So please go through and check your answers to 533. All of these answers are in there, and if there's anything that you were unsure of, that you don't understand my answers, or you didn't understand anything like that, please come and see me. That should cover everything we've done for this immune system thing. Please also, if you haven't, please also check out the video for blood typing. So you're ready for the blood typing lab, which will be the last lab and last activity we're doing for this year. So please be prepared for that. When either if you're coming Thursday afternoon for the makeup for it, or if you aren't taking the keystones, you'll be doing the lab Tuesday and Wednesday, so please be prepared for that.